So the whole thing with the 3D sound fields, right? And if we just kind of play it from here, from the top side view, right? If we look, the one tool that we have, or the tools that we have to work with, right, in terms of working with this, is a pan pot, right? So if we have a panner, that moves the signal between the left and the right speaker. Okay, so we can move the signal from the left and the right with a pan pot. The volume control, right? So this is panning, and the volume control moves things front or back, right? So the lower you make it, the more it disappears and recedes towards the back. So louder things are going to come up up closer to us. Softer in level, it will recede back. The panning will move it left-right. So it's very often, it's like a good habit to have, especially if you have a work surface, that as you are setting your levels, you are also panning the audio signal at the same time. And by panning the audio signal while you are adjusting the level, then you can place anything, anywhere. Because what you may have, for example, is you may have an acoustic guitar which sits here. And if you move the electric to that same location, then they will start to interfere with each other and cause problems. But if you decrease the level of the electric, you can make it sound like it's behind the acoustic, and then you can hear both of them. And there are many ways to do that. So the left, right, and the level, the panning and the level affects the front, back, left, right panning. The frequencies affect up and down and front, back. Okay, so there's a connection there with the front, back. When you work with equalizers, equalizers are basically volume controls for individual frequency areas, right? And they'll have a shape. They can have a shape that is a bell shape. It can have a shelving kind of shape. It could be a filter that rolls off frequencies. So essentially, what we're doing here with an EQ is we're adding or taking away volume within particular frequency bands. And if you were just from the previous graphic here, right? If I show you, this graphic with the front back stuff, then by shifting frequencies, say less maybe here in the low mid, you may be able to bring something and make it more focused and come out front. But it's sort of like puzzle pieces, right? Everything kind of fits together, right? One bit at a time, right? So we have all these tools. Compression is a form of volume, right? It's dynamic volume, okay? So it's dynamic volume control. And so what a compressor does is a compressor controls the attack, decay, sustain, and release cycle of the audio signal. And that allows us to make the transient peak stick out more, which is like making the volume stick out really high. Then when the compression gets in, the volume gets pulled back. So the signal will jump out of the speaker, but then recede back into the speaker very quickly, right? When we have a drum kit, right, where we hyper compress the drums and get that pumping and breathing, that's like a front-back movement. The front-back movement can start way up in front of the speakers, right? Or it can start way in the back of the speakers, right? So these are things that we can play with, right? That's the whole idea. So with the compression, we have this ability to change the dynamic movement front back, and that's why that pumping and breathing compression can create a big drum sound, because what it's doing is it's taking the room sound and moving it back and forth dynamically with volume control, right? So does that make sense to you guys, right? Is there anything, because I can actually, kind of blab on and on and on here. So if you have any particular questions about that, now would be a time to kind of ask about that, right, and get into that, because this makes up the whole 3D sound field, right? And so there are different things that equate distance, right? For example, the farther away something is, the more filtered it is, right? So high frequency energy gets lost over distance, and low frequency energy also gets lost over distance, because that low frequency energy transmits into the ground and gets lost as energy in the ground, right? Mechanical vibration. And so it's usually very middly mid-range frequencies that travel long distances. The closer something is to us, the more articulate detail that we hear, right? And so we get a fuller spectrum of the frequencies up closer to us. And so as you go farther away, the signal will get filtered or thinner. If you want something to sit way back in the speakers, you're going to have to filter some high frequencies and probably low frequencies to create that sensation that it's farther away from you, right? As opposed to close and up front. All this stuff is related because if you want something to sit back in the speakers, then you want to attenuate the transient peak, right? So we talked about the attack, decay, sustain, and release, right? The attack is the initial transient peak. Then there's the initial decay, right? The signal drops off a little bit, the sustain, and then the release cycle. If we trim off this attack, that will make the sound more distant because the farther away something is, the more that transient peak kind of gets softened over distance. It loses energy. And therefore, if somebody hits a snare drum and it's 2 inches away from your head, it'll hurt like hell. If it's 20 feet away from you, it will sound more balanced, right? And it won't be hurtful at all, no matter how loud they play it, because the transient peak will be much closer to the rest of the tone of the rest of the drum. Having a fast attack, okay, makes something sit back in the speakers. It cuts down on the transient, right? We're going to get into this in more detail, right, with the dynamics processing, right? But this is a real key thing, right? This whole thing, right? So dynamic front back is volume. Pan pod is just simple. That's just like a static thing unless you automate it for left and right. And then the frequencies, right? EQ, right, is level controls within different frequency areas. And therefore, when you're moving those things, when you add frequencies in the 2 to 6K range as a presence frequencies, it'll pull things up towards you, right? If you take those away, it will recede it back into the speakers. So all these things, right, play in. So width controls are mostly about modulation effects, right? And the depth is also enhanced by reverberation, right? So reverb, and in particular early reflections, I'm going to have like a whole huge thing on early reflections. Early reflections are those first reflections that bounce off the walls and hit us generally within 20 milliseconds. And those early reflections merge with the original signal and they create a tonal coloration. That can work for you or against you. If you actually mix some of those early reflections in, short delays, very, very short delays, less than 20 milliseconds, a whole grouping of them, you can get a perception of space. You can actually literally pull the sound that you're listening to out of the speaker and make it sound like it's in the room with you by mixing in just enough of the early reflection, not so that you hear it, but that so you feel it, right? You'll actually feel that the sound is now all of a sudden more three-dimensional than it was before. The reverb is just how reflective the surfaces are and at what frequencies they're reflective, okay? And that can help to create a sense of depth, okay? Pre-delay is a real big key. Pre-delay is the amount of time before the onset of reverb. The closer something is to us, right? If we have something that's right up here and the reverb doesn't happen until 20 milliseconds later, then the reverb, that gives the sense that the vocal is, let's say it's a vocal, is really dry and up front and close to us, but is in a big hall or in a big space. And so now the separation of the reverb from the voice by that pre-delay gives us a sense of depth in the mix, right? Important, because if there's no pre-delay, then the vocal sound with the reverb will sound more distant, okay? Technically. But if you're also adding in a lot of high-frequency presence, then one thing is going to be trying to pull it up forward in the speaker, and the other thing is going to be trying to suck it back into the speaker, and you're going to end up with a big mess in the middle. So what happens is whenever something is out of balance, it's stuck in the speakers, between the speakers, right? So if you actually look at a set of speakers, right, and I'll do this just like from a front side view, right? Most people's mixes, when I listen to them, when people send me a mix, right? Most people's mixes are stuck here, right, between the speakers, right? That's where the mix is. All the sound is in there, and sometimes you get a little bit of front back depth, right? And sometimes you get some stuff that maybe like bubbles a little bit in the middle, right? Goes down a little bit. But generally you get this thing where the sound is more or less in this area between the speakers. And that means that there is discontinuity, right? Or between the way and the different forms of processing that you're using. So if you want something to sound more distant by filtering off the higher frequencies and the lower frequencies, putting reverb with a higher amount of early reflections and no pre-delay on the reverb, the sound will start to become more distant sounding, right? Because that's naturally how it would occur in an acoustic space, as opposed to having something way up front towards us, and which would mean that there would be a delay before we would hear. It would take longer before the early reflections come, and it would take longer before the reverb comes. And that thing that was right in front of us, we would hear all the articulate detail of that, be very focused, very dense in terms of the frequency response, right? Over time or over space, because sound, when it radiates from a source, it goes in all directions. And therefore, every time you double the distance, like you half the intensity of the sound, right? It becomes less dense. Okay? So the more fuzzy a sound is, the more distant it will sound. The more focused it is, the more upfront it will sound. And this is another way to use compression. Compression creates density, right? And it creates focus. So if you have a vocal and you really, really compress it a lot, so all of the lip smacking, the breaths, every little articulate, kind of tiny little detailed bit that you hear is only something you would hear if somebody was right up very close to you and talking. Okay? Because if they were on the other side of the room, you wouldn't hear that detail. It would be much fuzzier, right? And that's one way of using compression to make something very present sounding, right, from the original microphone. And it's why, particularly with vocals, they're recorded very up close, right? So that's the fundamental starting place of the 3D sound field.